In light frame construction, there are two types of walls. While their composition is very similar, fundamentally they are quite different. Load-bearing walls are designed to provide structural support. In other words, they carry the load from overhead elements such as another floor level or a roof structure. So, looking at this in closer detail, we start with the perimeter support walls. The structure from above rests on top of the wall, and the load from the upper structure is transferred into the top plate of the wall, down through the studs to the bottom plate, and through the platform system, ultimately being absorbed by the building foundation. In contrast to a load-bearing wall, a non-load-bearing wall provides no structural support whatsoever. Its function is purely space segregation. So, what do we mean when we say space segregation? Well, if we look at most buildings with only their structural wall system, what we find is an interior space that is mostly open. Oftentimes, buildings such as homes, offices, and institutional spaces do not utilize one big open space. They're broken down into smaller, more usable spaces, and this is accomplished by constructing separation walls, or what's commonly called demising walls. They have no structural significance. They simply provide separation of space. So, understanding the fundamental difference of these two wall types, let's go back and look at their anatomy. Regardless of the wall type, all walls will consist of three basic elements: a bottom plate, a top plate, and studs. In a non-load-bearing wall, the framing members would traditionally be 2x4s or smaller. And in a load-bearing wall, those framing members would be at least 2x4s and oftentimes even larger. Now, what do I mean when I say 2x4? Well, I'm referring to the dimensional thickness and width of the framing member. So, in this case, the thickness of the member would be 2 inches and the width would be 4 inches. So, in a load-bearing wall, when elements such as doors and windows are introduced, challenges of load transfer have to be addressed. In order to create an opening in a wall, we have to remove studs. And remember, on a load-bearing wall, the studs are transferring the upper loads down to the foundation. When we remove those, that creates a weak spot in the wall. This void is compensated through the framework of the new opening. In this case, we start with a doorway. The opening starts with a full height stud on each side, creating the bookends of the frame. To the interior of each king stud is a jack stud that will establish the overall height of the opening by providing legs for the header to rest on. Now, the header is the most critical part of the frame because it transfers the overhead load around the opening, which means that it has to be a substantial piece of material. Commonly, a header is made up of multiple pieces of dimensional lumber sandwiched together with filler pieces between the layers. So those filler pieces are going to be typically plywood or OSB. Products such as LVLs, LSLs, I-beams, and timbers can also be used for a header. For the header to transfer overhead load from the top plate, which is ultimately what we're trying to get to, that load has to reach the header, and this is achieved in the last piece of the frame by way of smaller studs called cripples. With the cripples in place, we can now see how the load moves from the top plate through the cripples, across the header, and down the jack studs into the rest of the building system. So that's all there is to it with a door opening. Now, what if we had a window opening? Well, a window opening is accomplished much the same way as a door opening. Again, we remove studs to create the opening for our framework. The start of the frame is just the same as a door opening. But because most windows typically stop short of the floor level, filler elements are needed to close the space between the bottom of the window and the floor. The makeup of this is much the same as the head space of an opening. We have jack studs and cripple studs, and those support the horizontal element under the window known as the sill. Now, that's really all there is to it to creating a window opening. Very much the same as a door, just some added elements. So this can be a repetitive process from one window to the next. One thing that should be noted is depending on the load that needs to be transferred through the wall system and the size of the opening that we're creating, more importantly the width of the opening, there may need to be multiple jack studs on each end of the header to help support that additional load. Other than that, the process that we've gone through is exactly the same. So what if this were a non-load bearing wall? Well, in that application, the difference all lies in the head of the opening. Because we don't have an overhead load to worry about transferring, there is no need for the larger headers above the opening. In this case, those headers are removed and replaced with smaller headers, which are nothing more than the same framing material used for the rest of the wall. Again, if we were talking about 2x4s, then that header would be nothing more than a 2x4 turned on its side with larger cripples to extend down to the header. Now when I say larger, I just mean longer in length. Again, because there's no load to transfer, the only thing we're trying to accomplish here is filling in the open space above the window or door element so that we have something for our finished materials to attach to. So, as you can see, the makeup of these walls is very similar, but their fundamental differences combine to create a structurally sound as well as functional building.